Alrighty. Get this party rolling again. So, last week we opened this PR here on the cel-rust interpreter that adds like support for opaque values. There's been quite some discussion on that PR ever since I opened it. So let's start with reviewing those and see where we take this. So there's a few items that were raised that I think are interesting. Others, honestly, I feel way less. And yeah, so let's try to see how we can make this better. I think a follow-up to this will actually be opening an issue with the interpreter that actually clearly explains what the issue with the current function registration mechanism is. And so what I propose doing is actually explore fixing some of that in this stream, right? So one, probably come up with like self-contained examples that showcase the shortcomings of what we have today, and then see possibly start exploring things to try to make the life of users better. One, by having something that is actually proper overloads. I'll get back to what that means in a sec. If only because there is one weirdness with the current API that's been raised in this thread, and one of the threads on that PR that actually will illustrate one of the issues, right? So this, not that there's nothing that we can do about it, but like what would be like the proper fix, and what would it mean moving forward? Okay, so that's one thing. So yeah, so this is why I opened the PR here. That's all the stuff that's been discussed here. So what I'll do is I'll take some notes on a good old piece of paper. Sorry, my desk is a mess. So let's write things down on a piece of paper, and then we'll use those as to-dos of the things that we want to address in this session this morning. All right. So the PR got opened. I tried to give somewhat of a summary after the fact of how you would actually use that. So that's this bit here. And yeah. So, all right. So let me write a few things down. So here, John Howard says, nice. I ended up playing around with this on my flight and took a slight turn. Was no way to have things like JSON and so forth to work without a trait. I choose to make one primary function to turn the opaque into another value, presumably not another opaque. But other approaches could work. The as any is annoying though. Okay. I guess the as any is in this PR, because if my memory serves, we don't have this anymore, right? What we do is we force the thing holding the opaque to be an of any. So any is needed because like you don't have like runtime reflection like APIs in Rust, right? So we need to tell the compiler to record, hey there. Welcome, first time chatter. So in Rust, we need to have the compiler tag a type ID onto that type so that we can later downcast it to the type that safely downcast it to what we want, right? It's sort of as a blind cast, if that makes sense, which is actually an unsafe code block inside the standard lib. But it's safe because we recorded the type ID and we know we can check that the thing, the pointer points to is actually of the proper type that we're trying to downcast to. So I don't think we suffer from that in our approach. Blah, blah, blah. Okay, so that says outdated. So let's have a quick look. I'm curious. Oh, yeah. So why do we need runtime type name? As I say, I literally stole that from the Golang implementation. So if we click here, that should show us like how this works, right? So a type is always named in the Go interpreter. I think it's useful for debug information and so forth, but that's also how we then do the equality type and other, one of the issues that has been raised. Again, we'll talk about it in a sec. So no need to actually do this if you don't really care right now, but eventually I think you would need to if we move the dynamic dispatch to be handled by the interpreter. Okay, so actually I responded to that thing here. So that's related to inside this function here. So let me scroll back up here. If we do, so what this example does, it creates like a myStruct that simply has a field of type string. It doesn't really matter, right? This would be whatever it is that you're trying to inject inside the interpreter as an opaque value. So whatever state you need in order to do whatever the functions are that you want to expose on that type need in order to do what they do, right? So, okay, that's one. The opaque value is the trait that I need people to implement in order for me to be able to deal with your struct inside the interpreter. So the only trait right now that's required is for you to give me the runtime type name. I want to rename this. That's a mouthful. It's really annoying. I stole it from the Golang implementation, but we don't need to keep it that way. So yeah. So that's the one thing that I really need you to implement. Equal is nice if you do implement it, because if you don't, like no opaque values will ever be equal. So that could be not nice. See, that's one check here that actually I don't think we should be doing. Like we can have, we can move that inside the interpreter, right? Like especially now already. Actually, let's write this as a to-do in our case. Equality check on opaque to first equality check run time type names. That's one that's really easily implementable. As debug, same thing again. By default, this will return none. In the case we cannot get something that's debuggable from the opaque, it just debugs, prints it as an opaque thing. You don't know what's in it because we don't know what's in it, right? So in this case, we can just return some self because yes, we do derive debug automatically, so we can delegate to the debug thing. We'll get back to that as well in a sec because some proposals have been made in order to make this slightly nicer for the user so that you wouldn't even have to write this when your type already derives debug. So that's another one that we'll address, but I think it's raised further down. And then JSON here is effectively same thing again, something that lets me did we derive? Oh yeah, we derive serializable. So such sorted JSON can create JSON output for this struct here that I defined, right? So once I've done that, what I need to do is register like this, my function type to as a function, then now somebody can invoke. So the way that this works today is like this, right? So you can, I do two things here. I create a context. There are no new APIs here, right? That's literally the way that today the interpreter works. So we create a context, we add a variable from a value, mine, that's the name of the binding. The value opaque, that actually has the arc new mystruct clone in it. So we have it in there. I don't know why I do it that way, because I could have just moved it in. That would have been fine, but hey, whatever. So that's one thing. So now I can reference the mystruct, not do anything with it though, because it's an opaque value, right? So this, nothing I can do. I cannot straight go reference this field here, for instance. I cannot do that, right? So in order to do anything useful with an opaque value, now I need to declare the functions that operate on that type, right? And that's done today, like even with the latest released interpreter, by simply adding a function where you tell the name of the function, and then you provide a function pointer to the function that needs to be invoked when somebody calls that. So here, what we do, that's a use case we wanted to enable, right? That mine, I can invoke my function, the method on it, so that takes target mine, and that returns value, which value is the field of yeah, okay, that's unfortunate. Value is the string value of the field inside my struct, right? So that's what we can do, and now I can run this, and yeah, as we can see, like this makes sure that indeed we get a note executing this program, we get a string with the value, a string of value, right, in it. So that's what we do. Now, obviously, there is one thing that probably somewhat jumps immediately at you, right? Is how did we make it that my FN here is being associated with mine? Well, we didn't. And that's currently the shortcoming that I'm fighting, right? So the interpreter doesn't know. It just so happens that there is a little bit of magic that you can use to know, well, to be used in the dispatching of your function, in this case, my underscore FN, which is declared right here, right, by the interpreter. But that's it. So in this case, I'm doing none of that, because all I'm saying is my function takes a function context, right? The compiler has some tricks to make sure that, for instance, if you wanted that only string get implemented here, like that, you don't need to deal with all of that. But it's just syntactic sugar. Oh, that's a shit word this morning. Syntactic sugar done by type inference, and that the compiler sprinkles on top, right? But so what we get to is effectively this now, right? So it's like, okay, can you tell me what this thing has been invoked on, right? In case it's a value opaque, then we look further. But if it's not a value opaque, what we're saying is we're returning a invocation error that just says, oh, that's not what I expected, right? I expect the value opaque, but I got a string in here. And then if it was a value opaque, then I go check if the runtime type name is my struct, the one that I expect, because an opaque, I could have 12 different opaque types in there, right, that rob different structs. So that's a question that's being asked here somewhere, right? Do I really, like, practically speaking, like, can I just downcast right away to what I want and not check the name first? Well, the answer is yes, you can, right? If you know that no other opaque value of a different type robs this particular struct. So you could, right? But here what we're saying is we're sort of doing it the other way around. So what I do is I make sure that it's the proper type that I expect. The opaque thing in it, I deref it, I downcast my struct out of it, I unwrap it, because if it's a my struct, I know, right, that it's going to be wrapping this guy. I just know it. So it's fine to unwrap here. Get the field, clone the value out of it, and make it into a cell value that is then being returned, right? So as you can see, nothing, like, there is unless I write a myFN dynamic dispatching function, right? There is no way for me to add the myFN function to any other type. I can if those types are mine in here, right? But this breaks like enabling composability, right? If we do it that way, there is no way for me to build, say, a library that people could import in their say context. I don't know how that will work, right? But where I declare a function foobar, if I declare the function foobar, that string here, right? That's now mine. Like nobody else can use it. So I think that's a problem. I think what we should do here is not add function. What we should maybe have is an add overload where you specify the name of the function that is to be overloaded and then provide possibly the target that it operates on and possibly the arguments that it takes. I say possibly because there is this case where a function is a function that takes no argument, right? I could have foo, open parentheses, close parentheses. It doesn't target anything, right? It's not a member function of a type. It just says foo, and it takes no arguments, right? So it could be targeting none and take no arguments, an empty list. But in this case, what I would want to be able to say is add overload my function on this type here, this very type here, so an opaque type value here, and takes no arguments. That's really what I would want to be able to express. But that's today not possible. All right, so what else we have here? Yeah, the JSON marshalling thing, that's a bit annoying. But as I said, we covered that, right? So eventually I added it as a to-do on the issue and eventually added this thing that if you have, because it's a feature inside the which is in itself also possibly an issue, I don't know, but just makes things a whole lot complex. And if the point is to get to a cell compliant interpreter, JSON is not an option. So I don't know why it's being built as a feature in the current implementation. But anyways, so that works. So we can ignore that comment. Yeah, unsafe. We don't need any unsafe. We solved that without unsafe. Yes. Yeah, the delegation model here works. One, as we covered in the previous stream, opaque is the way that optionals are implemented, proof being here, right? So optional type is a new opaque type of name optional type. And now stuff can be delegated to the thing that is within the optional type, right? Think of optional a bit like option in Rust, right? Either it's a none or it's a something. And so if you would want to unmarshal a something to JSON, you just delegate to the something that you're wrapping, right? So this enables that. So what do we have here? Yeah, arbitrary has been, as we saw in the previous stream, quite a problem. So that one I think I can resolve. Yeah, that created a whole lot of discussion. I'm just going to resolve that. And move on. But so what we also did, so that you can see it, that PR has been closed and merged. I opened another PR. The reason we used this arbitrary was for the fuzzing bit. So what I did is I changed all the code to have the main crate not be dependent on arbitrary anymore. It doesn't need anything of it. And I unrolled the macro and some changes to implement the arbitrary straight inside the fuzzer code here. I think it's this file here. My memory serves. Yes. So all is implemented here now and does the arbitrary. for it. So what I did though is here we're off by 1 here. Can I change this? Where is the little gearbox? Here it is. Unified. That's going to be nicer to read. So what I did is here, when I'm trying to build, yes, here. When I'm trying to build a cell value, I'm off by 1. We actually have 12 variances on the enum value, but I am not trying to build a opaque value, right? What am I going to do with an opaque value? I could put like a unit type in it, but nothing else, right? Like nothing can read, like as the name says, right? Opaque's opaque. You cannot reach inside of it. So it makes no sense to have that being created on the fly. So anyways, so that solves that problem. So back to, back to 222 as a PR. And here we are. So we resolved that. What else is going on here? Need for permits, is there a reason we don't use opaque? Okay, yeah, I wasn't sure. I'm always on the fence there. So I think what I sort of flipped the argument on its head. Now opaque is just gonna be opaque. It's gonna collide with the variant, the enum variant name, but I don't think that's gonna be a problem. You'll probably always use it in the context of the enum anyways. And so it's going to be called opaque. And I think a good approach there is to just have type be the suffix on types instead, because you'll probably be using values more often than you'll be using type instances, right? So yeah, the arguably type instances are values in the Go interpreter, but we don't need to do it that way here. Okay, so that's another to do for us, is rename opaque value to opaque. That's going to be straightforward. Then what we also want to do is have all types. Even though I created a bunch of them, they do exist in the code base. I think it's mostly dead code, but so I have all types. Have suffix type. Well, we'll look into that in a bit as well. All right, keep on going. The beauty of open source, many people chiming in. There are good ideas, though. I think it's going to make for a neater API in the end, and that's great. All right. Oh yeah, that's another one. I think yes, it should be addressed. Documentation, like because of the types that need to be implemented and what it means. So I think we need to document the opaque trait is what we want. Doc opaque trait. I think that's important because yeah, people will need to implement those things. So I think even not only the method, but like the type itself and have all that stuff explained. I think it's going to be really useful. So, and yes, it can be postponed, but you know, documentation is one of those things. If you don't do it, you never do it. So let's do it. Yeah, so that's a bit of a problem. Okay, so this one is interesting. So what we want, what's being proposed here is to have some stuff becoming actual traits themselves. Sorry, I'm reading quickly because some cannot be, right? The opaque debug and the opaque equal, right? So, and then if we have those traits, all right, here we are, right? So I'm going to call them like cell equal and cell debug because I think it's going to be a recurring problem, right? Oh, interesting though, that we cannot, yeah. Oh, what is that going to be then? Because those are dens, right? So they need to be trait object compatible or den compatible. I'm unsure what the latest proper way of naming those things are. But yeah. So yeah, and actually that's the same. Oh no, that's debug. That's different. So wait, as debug, and that returns the option thing. Okay. And the idea behind having those types is because they map one to one to standard library types. So what we can do is this trick here. So that's providing a blanket implementation for things that have certain traits. So let's talk about it. That's funny that any got moved in there. Like we actually don't need it with that type, I think, but we do need it for, so it's not a requirement, but we will actually need it because I don't think if we call it cell equal, right, it needs, oh, though if it's cell equal, I could make it a cell value there. Well, we'll look into it. But again, the idea is the blanket implementation for those types, so that people don't need to do those things that we saw up here, like this code here, right? So like if you don't override the default implementation of as debug on your in your own implementation of the trait, like you will not get debug information. But what we can do is provide a blanket implementation. If your type does implement debug, which it does because here we derived, we can use, I don't know where it was, but this blanket implementation, wherever it was, automatically, right? Oh crap. Where was our code? Here, right? Opaque, where is opaque debug? Here's opaque debug, and then we go into, that can all go away, as you can see, but it still remains good because what we have is the implementation for any T that is debug, any send and sync. Arguably, I don't think we need none of those three. I think we only need the debug if that's good enough. Oh, maybe not. Maybe yes. We'll see. For any T where this is true, we can provide this implementation right out of the box, right? And we're happy. So no need to sweat it. Equal is a little bit like this weird guy because the reason it's not object trait safe or whatever, right, is because the right hand side operator, like, or other, right here, needs to be self, and then there you go, right? Like we cannot implement that. So if we make the cell equal, then what would that be? Well, I think it would be a cell value, right? So that's what we mean really. For all those things, it's actually value, right? Yeah. So here we can say for anything that implements debug and, can we do that? Yeah, we can. And opaque, right? Then we can do this right away. And we're done. I think that's really what we want to express, because we don't want to implement opaque debug for like all the debugs, right? Though arguably if nothing uses it, it's probably fine. And then we can fix all those code paths here. So that's great. So let's do that. And then what else do we have here? Okay, let me write that down though. So extract cell debug and equal plus blanket impulse plus blanket impulse. I'll do that. All right, what else do we have here? Yeah, that's the stuff that I get all that, but that's the stuff that I really don't want to do because that's moving it for the compiler and it just is easier for people to use. But like this is not the way we should do that, period, right? Because of the point I made before. So yeah, that's another fix. in the opaque. What is it? That's the debug one, right? Yeah. Fix debug on really opaques. Well, actually, I think on all of them. Fix debug to include opaque type name. I think we should do it, whatever. Again, like it's, I don't see how that's gonna hurt. Just current, yeah, that we discussed. Sure, that. Sorry, what is that? Yeah. Yeah. But yes, possibly, but I don't think none of that is going to work because what we need is to fix the dispatching first, and then it's going to look different anyways, right? And actually, I think we can even make more guarantees if we know, for instance, what the argument types should be, right? Downcast, yeah, we can provide an implementation of that for that. Oh yeah, because I made the din thing, and we can have it straight on arc self, and then I think it doesn't need to be dereft in that case, right? I'm cool with keeping the same name. All right, so that then triggered this entire discussion. So where there's a bit of confusion, right? So as I'm saying, right, like, and we can look at this code here, right? From say, the way this works is like this, right? Like you provide an overload, and the overload actually, like whatever the name of the overload is, then these are the argument types that we take. What I think that's what this returns probably. Wait. Subtract, yeah, so that's a return type, even that's specified, right? So knowing the return type is very valuable because we can do, and that's what Clark is referring to here, which is the check phase, right? So that we can validate that when you call a function, we know what it returns. So if you call another method on the return type, we can make sure that that method actually exists preemptively. So yes, absolutely. But it's not only that. Again, and that's what I want to try proving here, is what I'm saying here, right? So size is a method that exists on lists and maps. I'm fairly confident that there is no way for you to add size to any other type, because the keyword size, well, size becomes a keyword of the way that it's being used, right? So yeah, I think that ends it. So let me show that quickly, sort of so that we all agree what we're getting into. I guess it's probably here. Is it not? Size? What did I do? Slash size. Right? So that's the function, right? So, and as you can see, what this, wait a sec, where am I? Function. Size, right, here we are, right? Size, there you go, right? See, that's the dynamic dispatch I'm calling about, right? But because that I was talking about, because now this thing goes, all right, you can call size on list, on map, on string, and on bytes. Otherwise, sorry, we don't know what we're supposed to do. Yeah, awesome. So how can I add like effectively a branch to this match, right? I can, there's no way for me to do that. So we'll explore that later. And that's a bit the problem that I have with the way that we add functions. So even though all the sugarcoating, the syntactic sugar magic thing is kind of nice for people calling, like writing the function, it is great. Only it's the way that certain decisions have been made, like make certain things plainly impossible. More importantly, those things have to be supported based on the language spec, right? This is the way that overloads are supposed to work. I cannot overload methods in our functions, right? And interestingly enough, we know for a fact that that approach is going to break down at some point, because function overload is something that Rust explicitly decided to not support, right? In Rust, I cannot write a function that with a name foobar in the same, say, scope that takes one argument, then takes two arguments, takes one argument of one kind, then not of one type, then another argument of another type. That's I cannot do that, right? Like, in case it's not obvious, right? This is why you have vec new, but you have vec with capacity if you want to give it the size of what the underlying capacity should be for that vector, right? You cannot use new and directly pass 5 saying there, right? You need to call a different function. So there's only so much we'd be able to achieve anyways with Rust magic and so forth, right? So then can we infer from the function that's being referred by name, because that's where the problem begins, right? Maybe we need to have a list size and then a map size and whatever. Can we infer that what it operates on from that call? I'm like, possibly, maybe that's feasible. I don't know how, but maybe we'll figure it out. Worst case, I think having a macro for that could be one way, but it doesn't really matter, because in the end, what we need is this information to exist. So at some point, you will need to pass it to the interpreter so that we can create, say, a lookup key that says the function name is foo that operates on the type string and returns an integer value, right? Or size in this case, right? That operates on a string and returns an integer value. Oh, why is the size 64? Oh yeah, because assigned is the default, I guess. Anyways, whatever, it doesn't really matter. Yeah, so maybe we can do that, right? By magic, inferring all that and not forcing the user to say context.add overload and then specify all those things, because they need to match the function signature anyways. Maybe all that can be inferred. And if we can infer it, I'm all for inferring it. Don't get me wrong. I'm absolutely not interested in giving shit APIs for users to use, but we need that information recorded and available inside the interpreter so that we can do proper overloads, right? So that multiple parties can tell the interpreter, these are all the overloads for, say, the size. I'm going to call it a method in this case, right? So where now I make that available and it can be called. All right. So that's what we have. So we have at least 5 follow-ups here from this on this very PR. So that's what I think what we should look into. So I think I have the branch ready here. Let's make sure that is the case. So what is it? Control B. I think it's 1 probably, right? Yeah, I had some issues with my video for Linux this morning in OBS. I'm in GNOME, by the way, this time. Normally I'm in Hyperland, so it's a very different experience for me doing this morning. But yeah, I couldn't select a single window anymore in Hyperland. I think it's a Qt issue or whatever. Like, I don't really know. But anyways, this morning everything was broken. So, all right. So git status, right? So we're good. This is the branch as is. Git pull Alex opaque. we have everything local here, so we can switch back to our Rust rover here. So that guy works, because that one's also being somewhat flaky for me lately. And let's do that. I'll keep the doc part of this as the very, very last step, including after we have played, and if I have time for that, with trying to showcase what the problem is today with the function registration mechanism inside the interpreter. Because I think that's the most boring part. But for all the other ones, let's actually do that. So I wrote a thing down with the equal check straight inside the interpreter. So the interpreter exists here, and then we should have a thing somewhere that says what? Equal dot or as. No, either. So it's opaque. No, it's right hand side dot equal. Neither. I forget what the name of that function. I don't remember where that's happening. You know what we can do is we can actually go straight to our opaque. Actually, let's start by renaming things. Opaque value, right? So we said we want to rename that to opaque. Period. So let's do that. So that's now renamed. Did we have an opaque here? So that's the kind. That's fine. That we can keep. All right, cool. I guess we didn't have an opaque type yet. So I guess that's good for us. So that's a done thing, a done deal, right? So rename. All right. So that is check. Shall we? Let's actually be careful here. So let's switch to our cargo check first. Make sure that everything's fine. That seems to be the case. Cargo test. And life is beautiful. Cargo Clippy, maybe. Make sure that that's fine. That's fine. And then format everything. Git add -p. So that's a yes. That's a yes. That is a yes. And that is a yes. That is a yes. Git commit sm fix opaque. Refactor opaque value to simply opaque. Right? All right. Oops. Yeah. Maybe I want to learn. Commit. All right. Done deal. One thing done. So we've done that. So what we then said is to extract. That's going to be somewhat of a mess here, but let's do that anyways. Pub traits. And what did we say? We want to call it like cell equal. And yeah, only not self. Well, not cell equal. Let's call it equal. But we're gonna what we'll pass here is another value. I think that's the best shot at this, honestly, right? So that when is that correct? Actually, this may not be a good idea, is it? Huh. Why would it not be a good idea? Because what? because it can be an overload itself. Okay, you know what? I'm just gonna call it opaque as was initially discussed, and then have this be it then opaque, and then somebody does something with it. I think that's nicer. Option then opaque equal, and we make it so that we return none by default. Or should we force? Yeah, equal is actually a thing that you have to do. So you know what? I'm just gonna make it like that. So we'll have to fix that as equal. Bing, bing, bing. And now we can do the impl trick that we had discussed on the PR. And just provide a blanket thing. Just provide a blanket implementation for all those things, right? So what we want to do is, it's going to be really annoying. Sorry, I have issues with my keyboard and stuff. For T, where T colon, and all we care about is equal and partially equal, to be honest, right? And then we can just go straight to it now. God damn it, like, okay, this is gonna be a very interesting stream if things keep on going like that. All right, god damn it. Sorry, like, I don't know, like, I am not a GNOME or whatever it is I'm using right now, user, and like, focus should be here and somehow it isn't. Why can I not downcast to that guy? What? Other? Is this true? Yeah, that's a bit of a problem apparently. Oh, god damn it, I'm not even sharing the proper screen. Sorry. No, I don't want this to be a static thing. Does it? do I then need any and send and all that? I was wrong. Oh, okay. Yeah, no, the any makes sense, obviously. Yeah. We need the type information. Sorry, my bad. All right, so the descend and the sync we don't need. Like, I don't think that matters. Okay, so we have that. And so now this should technically break quite a few things. Right, because that's now gone. So we have the blanket implementation. So if we go to our test somewhere with the equality thing, if we run that, what is stuff has to be broken somewhere. I just don't know where. Yeah, method here is not. Yeah, well, we know that. So now we can delete. We should be able to derive equal and partial equal of this. Equal, partial equal. Is that happy with it? Let's rerun all the opaque tests in one go. What is the other thing? Opaque. I don't. How do I rerun this test? Here. Right, because now, yeah. What is best here? Should we? That's where the opaque is probably somewhere, right? Yeah. The opaque equal, that's correct. So maybe we want to rename this guy. Oops, my bad. Escape. Where are we? Where was our bake? All right. It's just, otherwise we get this name collision thingy. That's annoying. Kind of stupid, but all right, let's skip with that for a sec. So that becomes like the opaque here, right? Come on, go away. All right, let's rerun this. This is what we want to run. Right. So that's solved. I don't know if you want to keep the name exactly as is, but we'll see in a sec. So where is our blanket impl? Here. And so we can now do the same. How do we best do that one though? Yeah, you know what? I'm gonna keep it as opaque debug. And maybe later I'll merge them all into cell stuff, as I said that I would do. Because I don't know that I really want to do this for all of them. Import T opaque debug for T where T where T opaque debug. No, debug plus any, right? That's again all we care about, I think. That's all we cared about partial equal up there, but that's a different issue. And now we can actually do our actually, yeah, let's do this differently. Yeah, we need an option here because can this ever be none? Right, some self. But then should we? What is the problem here? Oh yeah. My bad. Debug, but I'm like, we don't need that. We can go, I think, straight like that. Because do we need to ever provide the implementation that returns? Oh, God damn this self, right? What is the issue here? Oh yeah, sorry, my bad. We don't need that here. Okay, so I think, wait, where is unwrap or as debug? And no, it's not unwrap or. As debug is all we care about. Whoops, my bad. What is? All right, let's rerun the test. I think I had one as debug. You don't care about that one either. Right. So there you go. So that makes the life of the users somewhat nicer with that specialized trait, right? And the blanket implementations. So again, just to be clear, if we go down here and now we get rid of example given debug here, like this should not compile, right? Because it's going to tell us that opaque debug here is not satisfied. So in order to do that, I need now to manually implement that trait if I wanted to if I wanted to do it manually, right? Or just again redo this, and now blanket implementation kicks in, and off we go. All right, so that's sort of the good news. I think that's not too bad. So we done that too. Extracts the ding-a-ling. We've done that. Yeah, actually, what we did isn't entirely correct, to be honest. So, because I think if we go to the equal fun code somewhere, wherever that happens, here, right? Opaque equal, and that's then implemented for all of those, but that's not correct. What we need to do is if self dot false. There we go. I think that is nicer because now we don't need to, like, this was just straight jumping to whatever the thing underneath is, right? Which in our case was my struct, but we also want to make sure that the types are the same first, right? So this now does those two things in one go. Then what we wanted to do is add in the debug thing, usage of that, yes. Here, I think here we always wanna add the o dot runtime type name, I guess, right? And we need to add this here somehow. I'm not sure how to best do that. Maybe like that. Right? So now if we rerun the test, that should fail because I don't... Oh, interesting. Did I not have a test for the... Why isn't this telling me here? How did I call this guy again? My struct. My struct. That's what should happen. Oh, what? Was I running the wrong test before? Oh yeah, okay, that's fine. Okay, so that we did too now. Fix the debug to include, that's done too. And first equal on the thing that we've just done as well too. I should have committed a bunch of those things as different as different commits. I don't know that I can do that in a nice way, so I'm just going to commit all of that as one. That's sad, but okay, happens. Okay, so let's do that. Go back to our terminal here, git check, cargo check rather. All right, cargo clippy. That's fine. Cargo fmt, git commit sm. No, ISM this time we commit everything. It's quite a few things that we did, right? So feed opaque You know what? I'm going to do this like this. Feet opaque PR comments addressed. And so what did we do? We did extract opaque equal and opaque debug as their own traits. Opaque requires the two traits above, provided, what did we do? We provided blanket implementations for those traits delegating to stdlib ones. Then the other thing we did is have default equal check on run time type name first, then the negating to the opaque to the, you know what, ampersand then opaque opaque equal implementation. Alrighty. Git push Alex opaque. All right, that's done deal. That's pretty good. We made some progress. Like, that's been streaming for an hour. We went over the problem space, addressed the those comments, and we're gone, right? So, and we're done. So that's pretty good. So now I think maybe what we should do is try to showcase where a thing falls apart with the current implementation that we have here. This might turn out to be a much shorter stream than what I had expected, but hey, that's fine. Let's take it here. So JSON though is still one where like people like will have to deal with that themselves. Maybe that wasn't required either, actually thinking about it. Yeah, whatever. I think it's better that people actually think about that. What was the yeah, it returns none by default, so I think that's fine. We can keep it as is. Sorry, I'm pausing because even though like this one, the reason I called it opaque equal is because like I need to get a din opaque in here, right? Like I could make it a din any and then, you know, but I don't know. I think I like that better for now. And then here, actually, that could be as debug. Not a. It doesn't need to be an opaque. Like it literally doesn't care about that. I'm even thinking. Let's try to do this. Actually, rename. Whoops, as debug. Right? Because we don't need that, and I don't think we need that. Right? I think if we do that, that's all fine. Let's see, right? Because possibly I'm wrong. But no, I'm not. And that's it, right? That is kind of nicer because there is no reason for us to needing like the opaque here, right? That sort of magic here, which we do here on that trait, right? So it has to sort of be that. So there is another way of doing that, right? Which I think would be this. Sorry. I think if we do this, that's fine too. Right? Oh, you didn't see, like I just ran like all the tests on the terminal here. I think now if I redo this, that's not working. Oh yeah, because the equals needs the runtime name. So there you go, like equal, because we folded that in, right? Maybe that was stupid to begin with, but I don't think it was. So we want that to be opaque. And then if I go check what the opaque definition is, that is any sensing. Yeah, that's somewhat annoying, that cyclic dependency there now. Wow. I can get rid of that here. So now something is probably broken here. But what I need to do is say that opaque needs to be opaque plus as debug. Oh yeah, we cannot do that. Indeed. Okay, well, there you go. That sucks somewhat. Sorry, I again forgot to change. Okay, so that works. What? Did I undo everything I did? Did I not? As debug. Then debug, implement as debug. You know what? I'm going to undo this. I'm going to do this properly. As debug. Do I need any here? Like that's probably all I need. Right. So if I go back to my terminal here, so that's what we have, right? The one downside here is sort of this with the opaque equal. We sort of run in circle here, right? Open equals where, oh no, that's the blanket implementation for that. That's sort of fine then. Yeah, that's fine. Opaque equals. And opaque is here, and that's our definition. Now what? I just change the order here because it annoys me a little bit. send and sync. Right. All right, let's redo this. Run all our tests, make sure that everything is fine, and that we're all dandy. Tests, cargo clippy, all features, cargo FNT, git add -p, so yes. Git commit dash. We're gonna amend this, and I'm gonna change this to as debug. Sounds straight. Opaque requires the 2 threads above for both threads delegating to the std lib ones, and bang bang bang, and life is beautiful. Git push Alex plus opaque. All right. Okay, so let's do the other thing then. So let's make sure that I'm not wrong to begin with. So maybe we can just use this as a thing and let's do that, right? So we're like equals dot size, right? So if I run this program, that should fail because now, all right, that's really bad. Result error, right? Cannot determine the size of int 1, right? So we're like, okay, not a problem. What I'll do is I'll do mute here, and I do context.add function size to my size. Right, so now I need this function, my size, that takes function context, ftx, function context, right, and returns a result of value or execution error, I think. Fn function results, my size, cell context add function, what? Okay, you know what? We'll just open the size function as it exists here. I'm just gonna copy this signature here. All right, freaking. But we called it my size, right? So let's see what happens if we do that. And we just said it always returns run 1, right? Return 1. Oh, we don't need that. As I64. Oh, I'm an idiot. Okay. Okay, so let's run that. Right, that's wrong. God damn it. So, because result, that doesn't make any sense, right? That becomes execution error. All right, run. So that passes it. But now if we do this, 1, 2, dot size, right? So that should very obviously fail. Because now, and that succeed +1, right? So, oh yeah, no, sorry, that should fail exactly, right? Because now that says false, but like this should be size 2, but this always returns 1 here, right? And so we can prove this by doing the magic thing that they like so much here. I don't remember how that goes, though. I'm gonna be honest, I don't find those magic things to be that nice. But hey, that's just me. Too much things, you know, magic is great if it gets out of my way. If I need to sort of keep it on the stack of my head, then that's not really useful, to be honest, right? So that's the thing, right? Starts with this on a string and it takes the prefix, so that's what we want. Simple. Let's see how that works, right? Oh yeah, I cannot paste either here for reasons that one day I'll oh, god damn it. This arc, this, all right, because that's the thing that does the magic. Okay, so how can I replace this here? Let me undo what I did. It needs to be this I64. I don't remember what the value is for an int. It's I64. Okay, so here we are. So if we go back to simple and now we run this, that's gonna fit with a different thing probably, because yeah, got list and one, see, like this all falls apart, right? So, you know what? I'm gonna cheat. I'm gonna do this. So this always returns the value that's there. That's what I did here, right? So if we rerun this thing again, and this fails, and if I make it here too, and I run it, right? Oh yeah, because TFTX now. Let's get rid of that. We don't care. Let's run this again, right? So the problem being that I want to clean that up because it really, I want this to be clean, that we understand what is going on, right? So this succeeds. This succeeds? Oh no, this doesn't succeed, right? See, too much crap. All right, so this failed, right? Because we get this problem here, right? And you know what? I can actually change this to do this and change that to not unwrap. That's gonna maybe make it somewhat nicer, maybe not, right? So Bing fails because unexpected type. Right? Because now size is completely shadowed. That's interesting that we do that, right? So indeed, when we add, we go and we add. And that's it. So what adds dot add size? Nothing does. Okay. So if we go here, if we go here and we search for what invokes size, where is our method? Size here, find usages. Oh, there you go. Here it does. Right? So that's the default thing. It does add all of those things. Now, all of those, if something adds it, shadows it. So now you need always at least know what called, see if somebody else wins, and then. All right, anyways, I think this showcases the problem here neatly on why you would want to have overloads, right? So again, I don't see how we best can solve that than than providing the information, right? So what I'll do next is I'll go back to our browser window, and we don't care about none of that, right? All of that has been addressed, like life's beautiful. We're going to create an issue, and I think have this here as a follow-up. Overloads. Oh no, that we don't care about that. Sorry. Do I not have this anywhere? Maybe not. Okay, so I'm just going to create an issue. New issue. Support proper overloads. So currently, functions are bound to the name they get registered under with the context. The problem is that this disables composing libraries of functions and types. As of today. Give me a second. Overloads should not only be resolved based on the name of the function invoked, but also on the target's type it is invoked on, probably in a option type for functions that are not methods, method calls, and the argument types and type. I'm gonna write it like this. I don't know whether it should be a ref to ref things or whatever. I'm a bit unsure about that, but let's make it that way. Current. Oops, Z. I've put together the shortest example I could think of that showcases the limitation of the current approach. Rust v. Bing. Right? Here, we'd like to register a size method on I64, or it's actually value int, I think, right? Let me verify this here quickly. Value int, yeah. Or more precisely, on value in type, that simply returns that value. Yet doing that, we shadow the existing size, dot size. We also shadow. Oh, we also shadow that exists for, I forgot what those are, so damn, this is really horrible. I honestly, fuck. You guys are missing what's going on, but trust me, it's pathetic. All right. That exists for list, map, string, for value, column, string, and bytes. Obviously, I could call into, where is this function? In to cell functions dot size if after having checked for the value for the targets type that was provided to my size function. Is that how I called it? My size, yes. But this forces a single delegation line, which makes it really hard to compose libraries with functions and types. All right, so that's it. I'm gonna add like one note to this possible solution. I know is attached to this easy to how easy it is to add a function today to the context. So maybe adding proper overloads alongside the current registration method. Registration. Might be a path forward. Something like Rust, import context, fn add overload and mute self, I guess. Let me see. Yeah, there's nothing. I am add function. I cannot even navigate to any of that stuff. This is horrible. Add function, yes, mute self. Okay, mute self, and then name, that would be a string, and then target, that would target, yeah, okay, that would be an option type, and args, that would be and you know what, because I made that an option type, I'm gonna make it like that here as well. To do implement me up where overloads would function calls would first try to resolve an overload. Would we? Probably not. Would first try to resolve functions by name as today to keep backward compatibility, right? And only then try overloads. That being said, all stdlib functions would be migrated to overloads as part of this. All right. That is it. That's what we're looking at doing here. I think this might work. This might be good. Maybe not. I don't know. We'll see. But so that's the thinking. So let's see where that leads. And we'll see, I guess, right? But in the meantime, we've moved a thing to be very, very slick, which is great. We'll see if anything more is being shared here or whatever, and see from there. All right. So that was a much shorter stream than what I expected, but I don't really have more for today until more of that gets settled and agreed upon. Another thing that I've been thinking about, though, is possibly forking the repo. Well, arguably I have it forked, right? But have sort of a branch where I just move ahead and implement things more according to spec, and honestly don't care about user experience initially. There's sort of two reasons for that. There is the say that maybe some of you know, which is first make it correct, then make it beautiful, then fast, right? So I don't really know where this comes from, to be honest. I was reading Learn a New Some Erlang book this morning. Maybe that's where this comes from. But I really agree with this, right? So I'm more focused on getting things correct for now. once we have them correct, we can see how we can refactor that, but the whole thing, right? To make sure that we have a complete understanding of the problem space we're evolving in. Then we can make it beautiful, i.e. refactor the code so that the code itself, the internals are good, but also possibly sprinkle again some syntactic sugar over things so to make the life of people easier. And usually once you've done those two things, mostly the latter for the internals, making things fast isn't too hard. Early optimization generally makes that a whole lot more of a problem. So again, I don't know where is this a quote from? Oh, that's a quote from John Armstrong. Well, there you go. It all makes sense. So yeah, so that's I think what I would want to focus on a bit, because this quite like this PR, we did all that work last week. It took 1 week to get it to, and then people, and I get it, right? Everybody has their life and work and whatever, but then stuff sits there for days, in this case, like a week. There's been discussion, arguably, but I think things have been pretty silent for like over 2 days now. And as I explained in the previous stream, right, we actually need a bunch of that work ourselves, and we need that stuff to actually work properly, right? So that's a bit of a problem when things remain there sitting for too long and blah 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 and so forth. It's a bit like the opaque was it opaque equal, and I wanted to make cell equal, and I thought it was a good idea, and it may still be a good idea because I know there is more stuff that we will need, right? If you go to the the cell Go implementation, right? I think there is a file that's called type. I think I can go straight to a file, right? Types here, maybe? What do we have in here? No, that's just that. Okay. So you know what? I'm going to serve maybe in the standard lib all that. Oh, it's inside standard. Is the name of the file. Standard go. All right. Do they define the types in here? Out variable. There you go. See, right? These are all the types that we need to support, right? So if you look at this list, oh, interesting. So those are part of, so that we got covered other than this one. Yeah, lists are generic types as well. I think we're sort of doing that more or less already. But so do we have any other calls of that? Where is type variable? Can we search for that? Oops, that's not gonna yield any results. Type variable, blah blah blah. So interesting. So where is the because there is this guy, effectively is what I'm looking for. I know it's there, I know it exists, right? There you go, it's right there, right? And the way they've done it in Go is that val, which itself is an interface, right, is the thing that checks for equality, right? So the way that you actually would do equality is not by delegating to the underlying equals contract like what we do in Rust, but instead you would have the value and val.equal or the value period and call it done, right? So if you remember this code here, actually I think it's an object probably, slash opaque equal, right here. See, right, this does partial equal for value, and then we go, oh well, Would that then be enough for us? Yeah, they need to be matching on the thing. Now we have this guy here because here we need to also check the runtime type. So that makes sense. Let me explain what I'm thinking about. I am trying to think whether we care about equal for like the din type. So in there's more types than the ones that you saw there, right? So din type is one of them. Where can I go to sell the din type? If I click this here, I go here. If I go here, will it lead me to the definition of that thing? Obviously no. Can I? No. Okay. So yeah, sorry. Not good at navigating. But so as you can, oh, actually I know where that is maybe. If I go here, I go here. Is this here? Right, so here we have the kinds that maps, arguably do map to type. There you go. Right, we have din type here. We have the any type, right? All those things we need to support. And the equal problem is going to be the same yet again, right? If it's an any type, right? I like from my perspective, if it's an any, I need to go check inside of it to know what it is. The same with din. Though arguably I think din on the, oh yes, I think there is stuff with JSON where something can be a din. I think if we go to the cell playground, we can actually somewhat easily see that if we do something like this. And I run this, this is gonna fit, right? So there you go. Here you can see that account dot optional navigation is there a bounce there? There is a bounce there, we know, right? It's right there. But see, that's applied to optional din. This is a din because all that stuff is, oh wait, that's failed to compile. That's on the compilation bit. So maybe I'm wrong because that's the compilation bit is what they call like the check phase, right? So I think maybe all that resolves at runtime, right? Come on, go away. If we compare the optionals, right? That's, oh, compile. Oh yeah, that doesn't work. But if we do if we do equal, that's gonna work, right? Oh, interesting. That, how does that work? Question mark? If I get rid of that one, run. Oh, look at that. It delegates. See, that's a fun one now, right? Because that's why it needs to be delegated to the thing underneath, right? That's in Opaque. We pass the other thing in. So our code that we have right here wouldn't work because, yeah. So actually what I was saying was probably the better thing to do. Sorry. Let me search here quickly. And that becomes like very interesting, right? Because what we actually want to do, where is our equal? Here it is, right? That's not what we want to do, right? Look at what we're doing here. Sorry, let me go back and clearly explain what is going on here, right? That returns an optional. And that then says like, is it equal to withdrawal? Here it says false, but I wouldn't be surprised if I make that 500. Oh no, it keeps on being false. Okay, so sorry, maybe I was too quick there. Okay, so that works actually. So anyways, but back to, that's literally the point I'm trying to make. Do we need to have, is a cell equal? Well, I don't know. Maybe not. Like, but if we had like the full understanding of like having build opaque, and used it to implement the optional type, support all the overloads and whatnot, we would be able to tell where stuff does fall short or not, right? Example given. Today I think, okay, let's go for opaque, and maybe we have a din equal as well trait, and maybe we realize they're exactly the same, and we can merge them, right? And then we have a cell equal, or whatever it is that we need, right? So anyways, that's, I guess, what I'm trying to get at. We'll see what gives. Anyways, that's it again for this time, for real. It was half a stream this time, but we made some progress again, so that's good. All right. Enjoy your weekend.